Hello and welcome to the MAML Manual. I'm Sebastien.
And I'm Iris.
And today we'll be covering 9 problems from Meet number 4, topic number 4, functions. So without further ado, let's have some fun with functions. Alright, here's the first problem of the video. This actually involves factoring a quadratic, so it's one of the easier problems of this video. Factoring a quadratic is something that we probably all know how to do already, but just in case, let's do a brief review. So f of x is equal to x squared minus 5x minus 8. Find all values of x such that f of x is equal to 6. So we have f of x, we're setting it equal to 6. So I'm going to say that x squared minus 5x minus 8 is equal to positive 6. Now, of course, we want to set this equal to 0, so let's subtract 6 from both sides. So it's going to be x squared minus 5x minus 14 is equal to 0. At that point, we make our factor x. On top, we have what we want to multiply to. On bottom, we have what we want to add to. We want to multiply to negative 14. We want to add to negative 5. So we're finding two numbers that multiply to negative 14 and add to negative 5. And the answer there is going to be negative 7 and positive 2. So your factors are going to be x minus 7 and x plus 2 equals 0. So therefore, x minus 7 equals 0, or x plus 2 equals 0. So we have x minus 7 equals 0, or x plus 2 equals 0. Therefore, x equals 7, or x equals negative 2. So the answer to this problem would be negative 2 or 7. And that is our final answer. Alright, so that was just factoring a quadratic, nothing too hard there. Let's move on.
Hello everyone, just a small editor's note. Throughout the rest of this video, I often refer to a function plugged into another function as a compound function. However, its actual term is a composite function. So I think I say it at least 10 times. I say compound function. What I really mean is composite function, okay? They're similar words, but I just want to make sure that you have the correct terminology. All right, so that's just my brief editor's note. Let's get back into the video.
Alright, this one involves a compound function in addition to some function subtraction. So this one is a little bit funkier than the last one, but this is starting to get into why this section is called functions. So let f of x equal 5x plus 3 and g of x equal 7 minus 2x. Find f of x minus g of x over f of g of x. Express your answer as a single fraction in simplest form. So the numerator is simple enough. Let's do that first. So f of x is 5x plus 3, and then we're subtracting g of x, which is 7 minus 2x. So we have 3 minus 7, which is negative 4. And then we have 5x minus negative 2x, which is the same thing as saying 5x plus 2x, which is positive 7x. So our numerator would be 7x minus 4. Now let's think about our denominator. We have f of g of x. What does that mean? Well, that means we are plugging the function g of x into f of x. So we have f of x, which is 5x plus 3, but instead of x, we are going to put g of x, which is 7 minus 2x. So we are replacing this placeholder with 7 minus 2x. So we say 5 times 7 minus 2x plus 3. From that point, we distribute the 5, so it's going to be 35 minus 10x plus 3, and therefore that would be negative 10x plus 38. So the denominator would be negative 10x plus 38, and that would be our final answer because there's no way to simplify this fraction. There's no common factor. Alright, so that one, just remember we have a compound function, and when we have that, we are plugging one function into another function. Alright, let's move on to the next problem. Alright, here's the third problem of the video, and in this one we have another compound function. So we have f of x, g of x, and we are saying that h of x is equal to f of g of x. Okay, so let's solve for h of x. So we are plugging g of x into f of x. So f of x is 4 minus 3x, but instead of that x, we are going to have g of x. So we are plugging 5x minus 1 into the placeholder that is x. So it's going to be 4 minus 3 times 5x minus 1. And from that point, we distribute. So the negative 3 to the 5x is negative 15x We'll keep the 4 there. And then distribute the negative 3 to the negative 1, and we get positive 3. So we have 4 minus 15x plus 3, and that becomes 7 minus 15x. So we have solved for h of x. This is h of x. And it's saying that this function is equal to 2, and we are solving for the value of x. So to solve for x, all we have to do is say that 7 minus 15x is equal to 2, and then solve for x. Well, we can move the 15x to this side, and we get that 7 is equal to 2 plus 15x. Subtract the 2 from both sides, 5 is equal to 15x, and then divide both sides by 15, and we get that x is equal to 1/3. So our final answer is 1/3. So again, that one involved another compound function where we plug one function into another function. Alright, let's move on to the 4 pointers of this video. Alright, so now we are getting into transformations of functions. So f of 2x minus 3 is equal to 6x minus 14. Find f of 3x plus 2. Alright, so it's important to know that if we do not have an x in here, but rather something like 2x minus 3, that means we are transforming the original function. So our original function is f of x, but our new function is going to be transformed. Now in this case, the 2 would dilate it, meaning it would stretch it out in the vertical direction, and the minus 3 would shift it downwards. Now it's important to note because it was already dilated, it won't just shift 3 units down, it will actually go a little bit further down, but that doesn't really matter for the purposes of this problem, because we aren't going to think about it graphically, but rather algebraically. So this does have a graphical meaning, but it's more important to focus on the algebra for these types of problems. So given that we're doing some transformations of the functions, and we result in a line, that means we had to have started with a line in the first place. So we dilate the function, shift the function, and result in a line, meaning that our original function must also have been a line. So we can say that our original function, f of x, is equal to ax plus b, right? We don't know the slope yet, we don't know the y-intercept. So let's do f of 2x minus 3. So we end up getting a of 2x minus 3 plus b. Let's distribute the a, so we get 2ax minus 3a plus b, and that would be equal to 6x minus 14. So from that point, we need to solve for a and b. Well, let's take a look at this x term. There's only one x term over here, and there's only one x term over here. So we could say that 2a has to equal 6. And if 2a has to equal 6, then a equals 3. So once we know that a is equal to 3, we can make a note of that over here. A equals 3. And then come back, and we say 6x minus 9 plus b is equal to 6x minus 14. Well, the 6x's are the same, so those don't really matter. We get b minus 9 is equal to negative 14, and therefore b is equal to negative 5. So we know that a is equal to 3, and b is equal to negative 5. So we have found our original function. F of x is equal to 3x minus 5. Now that we have that knowledge, we can solve for f of 3x plus 2. All we have to do is plug in 3x plus 2 to this function. So we have f of 3x plus 2, and that equals 3 times 3x plus 2 minus 5. Now, distribute the 3. 3 times 3x is 9x. 3 times 2 is positive 6. And then we subtract 5, meaning that our final answer would be 9x plus 1. So our final answer is 9x plus 1. So in problems like these, remember, find f of x first, and then find what they're asking you to, okay? So don't go straight from this to this. There is an intermediary step, and that would be to find f of x. All right, let's move on to the next problem. All right, this problem introduces the concept of inverse functions. So we have f of x, and it's asking us to find us f inverse of 2. It's a little bit pixelated here, but it looks like it's raised to the negative first power, but that's not true. We're not raising the function to the negative first power, but rather we are finding the inverse function. And that's similar for trigonometry. When we get to trig, the inverse cosine, the inverse sine will look like sine to the -1 or cosine to the -1, but we're not actually doing that. It's just how we denote the inverse trig, and it's just how we denote the inverse functions. Now, what is an inverse function? Well, if we have f of x and we have x comma y, x is our input, y is our output. We then have f inverse of x. For this point, x comma y, there is a point y comma x on the inverse function. That means that the inputs and the outputs are swapped. So if you want to think about this change geometrically, it means we are reflecting the function over the line y equals x. So for example, if this were our original function, you would flip it over y equals x, and this would become the new function. Okay, it would look something like that. So that's the geometrical representation. This is just how we think about it in terms of algebra. So if it's asking us to evaluate f inverse of 2, we could do it the hard way. We could actually solve for the entire inverse function, or we could apply what we know about inputs and outputs. If we are inputting something to the inverse function, that means it has to be the output of the regular function, okay? Input into inverse, output of regular. So we know that we're looking for the value of x that makes an output of 2. So all we have to say is that x minus 3 over x plus 2 equals 2 and solve for x, okay? So then we multiply the x plus 2 to both sides. We say that x minus 3 is equal to 2 times x plus 2. From that point, distribute. So x minus 3 is equal to 2x plus 4. Then subtract 4 to this side. We get x minus 7 equals 2x. And then subtract x on both sides. We get that negative 7 equals x. So our answer here is going to be negative 7. The takeaway here is that the inverse function flips the inputs and the outputs. So we have an input, get an output for f of x. We flip them for the inverse, y comma x, instead of x comma y. And again, geometrically, it would be a reflection over the line y equals x. All right, with that problem out of the way, let's move on to the next one of the video. All right, and we're back to compound functions. If f of x is equal to 5x plus 2 and g of x is equal to x squared minus 1, then find all values of x such that fog of x plus goff of x equals 10. Now, this is just different notation for compound functions. This means f of g of x. The circle here is kind of like an O, and that's how we know it's f of g of x. Here it's g of f of x. Okay? So let's do that. Let's first solve for f o g of x. And that's going to equal 5x plus 2, but instead of x, plug in g of x. So it's going to be 5x squared minus 1 plus 2, which is equal to, if we distribute 5x squared minus 5 plus 2, so 5x squared minus 3. So that's our fog of x. Now let's find goff of x, okay? So let's go to g of x first, and it's going to be x squared minus 1, but instead of x, we are going to plug in f of x. So it's actually going to be 5x plus 2 squared minus 1. 5x plus 2 squared would be 25x squared plus 20x plus 4. And so we have a plus 4, and then we subtract 1, so it's going to be plus 3. So now we have fog of x and goff of x, and we need to add them and then set it equal to 10. So when we add these, we get 30x squared, 20x, and the negative 3 and the positive 3 cancel. So we say 30x squared plus 20x, and we set that equal to 10. But because it's a quadratic, we know that we're going to want to set it equal to 0, so let's just subtract the 10. So we're going to say 30x squared plus 20x minus 10 is equal to 0. Get rid of the common factor of 10, so 3x squared plus 2x minus 1 equals 0. Then we have our factor x. We want them to multiply to negative 3 and add to positive 2. So multiply to negative 3, add to positive 2. That's going to be 3 and negative 1. So we have 3x squared plus 3x minus 1 equals 0. We can pull out a 3x, and the common factor is x plus 1. And then we can pull out a minus 1, and the common factor is, again, x plus 1. So in factored form, this becomes 3x minus 1 times x plus 1 equals 0. Therefore, 3x minus 1 equals 0, x equals 1/3. X plus 1 equals 0, x equals negative 1. So our answer is going to be 1/3 or negative 1. And that right there is our final answer. So this problem just presented another funky way to write f of g of x or g of f of x. That's just a compound function. And in compound functions, we input one function into another function. All right, let's jump into the first 5-pointer of this video. All right, this problem introduces the topic of recursive functions, which are pretty common on MAML competitions and are very fun to do, at least for me, in my opinion. So a recursive function is a function defined by itself. So we have f of x, and then on the other side, we should have some form of f of x as well. So it's a function defined by itself. The term might be familiar to you if you're either a programmer or if you remember from sequences and series, we have recursive sequences. The most famous of which being Fibonacci, which is just an is equal to an minus 1 plus an minus 2. Right? So every term in that sequence is the sum of the two previous terms. That's the most famous recursive sequence. Hopefully that just jogs your memory a bit. But now let's turn our focus to recursive functions. So let f of x be a function such that f of x plus f of 1 over 1 minus x equals x. For all x not equal to 0 or 1, find the exact value of f of 2. So before we do anything, I want to get f of x alone, just because we're supposed to have f of x on one side in a recursive function. That's how it's defined. So we have f of x equals x minus f of 1 over 1 minus x. Good. So now all we have to do is start plugging in values. Now it's not as easy as just plugging in f of 2 and getting our answer. We actually are going to create a loop, and you'll soon see what I mean by that. So if we plug in f of 2, we get 2 minus f of 1 over 1 minus 2. Now 1 minus 2 is negative 1, and 1 over negative 1 is negative 1. So we have f of 2 is equal to 2 minus f of negative 1. Well, what is f of negative 1? We don't know, so let's find out. We plug in negative 1 to our function, and we get negative 1 minus f of 1 over 1 minus negative 1. 1 minus negative 1 is 2, so we have f of 1/2. What is f of 1/2? We don't know, so let's find out. So plug in 1/2, and we get 1/2 minus f of 1 over 1 minus 1/2. 1 minus 1/2 is 1/2. 1 over 1/2 is equal to 2. So we are back where we started. We started with f of 2. Now we have something in terms of f of 2, so we have created a loop. Now we just have to be very careful about how we solve for the answer. We have to make sure the parentheses are all in the right place. So let's start with f of 2. I'm going to say that f of 2 is equal to 2 minus f of negative 1. But f of negative 1 is equal to negative 1 minus that. So in brackets, because we're replacing f of negative 1 with this, so it's going to be negative 1 minus f of 1/2, but we want to replace f of 1/2 with this. So again, more sets of brackets. We are replacing f of 1/2 with 1/2 minus f of 2. So that's what we are left with. F of 2 is equal to 2 minus brackets negative 1 minus brackets 1/2 minus f of 2. So now if we simplify the insides of this, negative 1 minus 1/2 is negative 3/2. So the inside becomes negative 3/2 plus f of 2. And then we have 2 minus that. So then simplify further, 2 minus negative 3/2 would be equal to positive 7/2. So we have 7/2 minus f of 2. So bring the f of 2 down. We say that f of 2 is equal to 7 halves minus f of 2. Add f of 2 to both sides. So 2 times f of 2 is equal to 7 over 2. Now to solve for f of 2, all you need to do is divide both sides by 2, and you get that f of 2 is equal to 7 over 4. So your final answer to this problem is 7 over 4. So that's a recursive problem for you. They're super fun. Remember how to solve this problem? First, isolate f of x, get it on one side, and get everything else on the other side. Then plug in your values. F of 2 equals this, but you can't evaluate that because you don't know what f of negative 1 is, so you have to keep on going until you make that loop. And once you make that loop, just be very careful about your simplification process. Alright, with that out of the way, let's move on to the next 5-pointer of this video. Alright, so here we have another compound function problem, but this time it's in the context of domain. Okay, so domain is the set of all valid x values for the function, and if it were asking about range, that would be all valid y values, or all valid outputs of the function. Okay, but we're dealing with domain, so it's going to be inputs. So we are trying to find, well, what are the valid inputs of f of g of x? So it's going to be very important to think, well, what do we mean by f of g of x? We are doing f of g of x, so we are solving for all of the valid x values, okay? So first, we need to start with g of x. If g of x is undefined, then we can't use those x values. So let's take a look at g of x. G of x is equal to 5x plus 2 over 4x minus 3. Now, most x values will be fine. That will result in a real number. However, the problem is we cannot divide by 0. Okay, so this denominator cannot equal 0. So we have 4x minus 3 cannot equal 0. 4x cannot equal 3. And therefore x cannot equal 3/4. So we have to remember that that is one value of x that is not valid for f of g of x. So we found the domain of g of x. Now let's think about f of x. So this is where we've got to be careful. We're going to find where f of x is not defined. Okay? However, that x value will be a valid input of the overall function. That might sound a little bit confusing right now, but I'll show you what I mean. So f of x is 2x minus 3 over 3x plus 2. So dividing by 0 is invalid. So we would say that that denominator, 3x plus 2, cannot equal 0, and therefore x could not equal negative 2/3. But we've got to be careful, because negative 2/3 is actually a valid input of f of g of x. What this means is that we cannot input the value negative 2/3 into f of x. This input is not valid. So it's not that x can't be negative 2/3, but it's that g of x cannot equal negative 2/3. Super important. X can be negative 2/3, that's fine. G of x cannot be negative 2/3. So if g of x can't be negative 2/3, let's solve for the value of x that makes that true. So 5x plus 2 over 4x minus 3, g of x, does not equal negative 2/3. Now, what I could do is cross multiply and solve, but look at what I notice. If x were 0, if these terms go away, we're left with 2 over minus 3. 2 over minus 3 is the same thing as saying negative 2/3. So if the x terms go away, we're left with negative 2/3. So x in this case would be 0. So we say that x does not equal 0. Okay, so that comes over here. X cannot be 0. So that's it. We're done. We have found the invalid values of x. 3/4 and 0. However, again, can't stress this enough, negative 2/3 is a valid input, right? Because we input it into g of x. Just to demonstrate that this is true, let's plug it in. So let's find g of negative 2/3. G of negative 2/3 is equal to negative 10/3 plus 6/3 over negative 8/3 minus 9/3. So that would be negative 4/3 over negative 17/3. So that would be 4 over 17. So the value of g of negative 2/3 is 4 over 17. So then plug that in to f of x, and that would be valid, right? Because we said the only invalid input is negative 2/3. But this is 4 over 17. So 4 over 17 would get you a valid output. So into f of g of x, we inputted negative 2/3 and we got a valid output. So that demonstrates that negative 2/3 actually works. So the only two values that don't work are 3/4 and 0. Now it's also super important how you write your answer. I would write the following: all reals except 0 or 3/4. So if you were to write that in full, it would be all reals except 0 or 3/4. So that is an acceptable answer. And if you want, you can shorten all reals to the symbol for all real numbers, which is a double struck R. So you could say all reals, and that's the symbol for all reals, except 0 or 3/4. That is the correct answer. Now, of course, there are other ways to successfully report domain or range, but I find this to be the clearest way to get across your message. I find set builder notation or interval notation is a bit messy. This clearly states what you mean. All reals except 0 or 3/4. All right, with that problem out of the way, let's move on to the final problem of this video. All right, let's do the last problem of this video. So this is actually solving for a quadratic function with 3 points. So the quadratic function f of x passes through the points 1, 2, 2, 5, and 3, 7. Find the value of f of 10. So to solve this problem, we've got to think about the standard equation of a quadratic. All right, so the standard form of a quadratic is going to be y is equal to ax squared plus bx plus c. With that knowledge, we're going to plug in our points to solve for the coefficients a, b, and c. So let's start with point 1, 2. We would say that 2 is equal to a times 1 squared plus b times 1 plus c. 1 squared is 1, so it ends up being 2 is equal to a plus b plus c. All right, next we have 5 is equal to a times 2 squared plus b times 2 plus c, and therefore 5 is equal to 4a plus 2b plus c. Lastly, we would have 7 is equal to a times 3 squared plus b times 3 plus c. So we would say that 7 is equal to 9a plus 3b plus c. What are we left with? A 3 by 3 system of equations in which we are solving for a, b, and c. Exactly what we need to solve for our function. So let's start. Let me bring this equation up here. So I'm going to say that 5 is equal to 4a plus 2b plus c. And let's just subtract these two functions. We can get rid of the plus c's. So we're left with 2 is equal to 5a plus b. All right, that's good. Now we could also subtract these two equations from one another. So if we write 2 is equal to a plus b plus c underneath here, and we subtract, we get that 3 is equal to 3a plus b. So let's move that over here. If 3 is equal to 3a plus b, we can now subtract these two equations and get a by itself. So subtract these two equations and we get that negative 1 is equal to 2a, and therefore a is equal to negative 1/2. So we found that a is equal to negative 1/2. From that point, we can solve for the value of b. So if 2 is equal to negative 5/2 plus b, if we add 5/2 to both sides, we would find that b is equal to 9/2. And finally, to solve for c, let's go back to one of our original equations right here. 2 is equal to a plus b plus c. So we would say that 2 is equal to negative 1/2 plus 9/2 plus c. Negative 1 over 2 plus 9 over 2 is 8 over 2, which is 4. So we say that 2 is equal to 4 plus c, and therefore c is equal to negative 2. So up here we can replace plus c with minus 2. So f of x we've now solved for. We would say that y, or f of x, is equal to negative 1/2 x squared plus 9/2 x minus 2. Now that would have been nearly impossible to guess just by looking at those 3 points, especially since they look pretty simple. So that's why we solve with the 3x3 system of equations. Okay, now that we have that, we're able to evaluate f of 10. So f of 10, we have negative 1 over 2, 10 squared, which is 100, plus 9 over 2 times 10 minus 2. Now, negative 1 over 2 times 100 would be negative 50. So we have negative 50. And then 9 over 2 times 10 would be 9 times 5, which is plus 45. And then we have the minus 2 to end it off. So it's negative 50 plus 45 minus 2. Negative 50 plus 45 is negative 5. Minus 2 is equal to negative 7. So our final answer, if there's any room, there's some room down here, is negative 7. F of 10 is equal to negative 7. Now, the takeaway there is that if you're given 3 points and told that they are quadratic, you can solve for the original function using a 3x3 system of equations. They could have asked you just to report f of x and you could have written your answer. They could ask you to evaluate a specific input like f of 10, or they could maybe even be crazy and say, okay, those are the points, find f of x, and then report f of 2x minus 5 or something, like do a transformation after you found the quadratic. Now, I haven't seen a problem like that. That would be pretty crazy to expect you to do in such a short time frame, but you never know what might happen. Maybe it's a team round problem, so just be ready for anything, right? They can combine multiple things. They can combine, as you saw in the last problem, they combined a compound function with a domain question. So, especially with these 5-pointers, you can combine a lot of the different skill areas you need into one problem, and that's what makes them challenging. But this one, all you need to know is 3x3 system of equations. All right, with that out of the way, that concludes this video on functions. This was our video on 9 problems from Meet number 4, topic number 4, functions.
Thank you for watching.
I'm Sebastian.
And I'm Iris.
And we hope you had fun with functions.